So we have defined A operating on n is equal to Cn ket of n minus 1. Okay, and A dagger operating on n is equal to Cn, okay, sorry, dn into n plus 1. Okay, this are proportionality factors, not eigenvalues. So now our aim is to understand this proportionality factors. Okay, so let me find it for this term. Now to do this, first of all let us find the Hermitian conjugate of this equation. So first of all, for uh, LHS, A into ket n Hermitian conjugate of this quantity will be equal to, similar to matrices. Okay, so suppose that if you are having two matrices A and B, then you generally write this as B dagger into A dagger. Okay, so similarly in quantum mechanics also, you have this A operator, which is nothing but a matrices. Ket n is also a matrix. Okay, so this can be written as ket n dagger into A dagger. Okay, so now the ket n dagger is nothing but equal to bra of n. Okay, and so I can write A into ket n dagger is equal to bra n into A dagger. Okay, so this is the quantity which I have. Okay, so this can be written as ket n into A dagger, and for for RHS I have Cn into ket of n minus 1, and I have to take the Hermitian conjugate. Okay, so I will be having ket of n minus 1 into Cn. Cn is just a number, so its Hermitian conjugate will be just simple uh, simple complex conjugate. So now if I multiply this equation, this star equation, with its Hermitian conjugate, then what will happen? So if I multiply A into n with its Hermitian conjugate from left, then it will be ket n into A dagger into A into ket n, and this will be equal to ket of n minus 1 Cn star into Cn into n minus 1. So this will be equal to, so Cn is just a number, so Cn star into Cn I can write as mod of Cn square and ket of n minus 1 into n minus 1, and okay, so this is the quantity which I have. Now see what does this thing is generally is known as inner product. Okay? And actually it actually represents, okay, this thing psi of n minus 1 star, okay, which is this term, into psi of n minus 1 dx. So these are the both wave functions of the same state, into psi n star into psi n minus 1, and integral from minus infinity to plus infinity. So you know that for normalized state this quantity is always 1. This is just a normalization condition. So this term will be equal to 1 for normalized states, and as we know that in simple harmonic oscillator we generally take normalized states. So n into A dagger A into n is equal to mod of Cn square. So this is the thing which we have. Now, we know from our definition of Hamiltonian operator that it is equal to h cut omega into a dagger a plus 1 by 2. So this can be written as that a dagger a is equal to Hamiltonian operator by h cut omega minus 1 by 2. So what I will do is I will plug this quantity in this equation. So instead of writing a dagger a, I will write h upon h cut omega minus 1 by 2. So this is n into h upon h cut omega minus 1 by 2 into 1 is equal to mod of Cn square. So this thing can be written as n. So I will take 1 by h cut omega outside, n into Hamiltonian operator into n minus 1 by 2 n into n is equal to mod of Cn square. So this is again the condition for normalized states. So this is equal to 1 and this is equal to 1 by h cut omega, and as we know that when h operates on state n, okay, you will get h cut omega into n plus 1 by 2, okay, equal to n into n. So why you are getting this n, just wait for some time, I will let you know. It's for now, you just keep this in mind. So I will write this equal to get n into h cut omega n plus 1 by 2 into n minus 1 by 2 is equal to mod of Cn square. So 1 by h cut omega will come outside into h cut omega into n plus 1 by 2, okay, into n, and minus 1 by 2 is equal to mod of Cn square. This thing is again equal to 1. H cut omega will cancel out. You will get n plus 1 by 2 minus 1 by 2. Okay. So this is equal to mod of Cn square. So you can see that 1 by 2 will cancel out and Cn comes out to be root of n. So how we have defined that when A operates on n, there will be a Cn coefficient into ket of n minus 1, which is one state lower than n. So A of n is equal to root of n into ket of n minus 1. Okay, this is again a very important identity. Okay, very important identity. Okay, and similarly, okay, when you will solve for dn, you will get a dagger operating on n is equal to n plus 1 ket of n plus 1. So here their coefficient will be under root of n plus 1. Okay, this are two very important equations. This is the equation for lowering operator, and this is your equation for raising operator. Okay. When we are talking about quantum mechanics, so single particle quantum mechanics or harmonic oscillator, we call them as a lowering operator and raising operator. But in quantum field theories and other branches, we come across the same type of operators, but there we call them as annihilation operator, so the lowering operator is generally known as annihilation operator, and this raising operator is generally known as creation operator. Okay. In fields such as quantum field theory, when we are talking about bosonic particles, we come across same states. Okay, and there basically these operators are responsible for creation of an photon and destruction of a photon. So here those things come into play. But here we will use this terminology, lowering operator and raising operator. Okay, so this was our discussion on lowering and raising operator.